Can you solve compound inequalities that have decimals? Have you ever wondered if you can tackle compound inequalities that include decimals? The answer is yes, you absolutely can. Solving these inequalities is much like solving those with whole numbers. Let's break it down step by step to make it clear and simple. First, understand what a compound inequality is. It consists of two or more inequalities connected by the words and, or. When you see and, it means the solution must satisfy both inequalities at the same time. On the other hand, or means it must satisfy at least one of them. Next, you will want to solve each inequality separately. This is where you apply basic algebraic operations like addition, subtraction, multiplication, or division. When you work with decimals, just treat them like whole numbers. The process remains the same. A key point to remember is the direction of the inequality sign. If you multiply or divide by a negative number, including decimals, you must reverse the inequality sign. This is an important rule that helps keep your solutions accurate. Now let's combine the solutions. For compound inequalities connected by and, you will find the intersection of the solution sets. For those connected by or, you will find the union, meaning all values that satisfy either inequality. To illustrate this, let's consider an example. The compound inequality 0.5x minus 1 is less than to and 1.2x plus 3 is greater than or equal to for 0.5. Start with the first inequality. 0.5x minus 1 is less than 2. Add 1 to both sides to get 0.5x is less than 3. Now divide both sides by 0.5, and you find is less than 6. Now let's solve the second inequality. 1.2x plus 3 is greater than or equal to for 0.5. Subtract 3 from both sides to get 1.2x is greater than or equal to 1.5. Then divide both sides by 1.2, and you find is greater than or equal to 1.25. Since this is an and compound inequality, we take the intersection of the two solutions. So we have x is greater than or equal to 1.25 and is less than 6. In interval notation, this is expressed as 1.256. Working with decimals in inequalities is common in real-world situations, such as finance, measurements, and science, where precise values are important. By breaking down the problem step by step and treating decimals with the same rules as whole numbers, you can confidently solve compound inequalities involving decimals. Graphing the solution can also help you visualize the range of values that satisfy the inequalities. This not only reinforces your understanding but also makes it easier to see how the solutions relate to one another. So, yes, you can solve compound inequalities that have decimals, and with practice, it will become second nature.